Alright, these are notes for Algebra 1, Semester 2. This is sections 6-1 and 6-2. And we're going to talk about factoring. Chapter 6 is the beginning of factoring. So factoring polynomials is the name. Example 1 says find 5 factorizations of 15x to the third. Now let me give you the hint. The hint is, what two terms would you multiply to get 15x to the third power? And you can use positives and you can use negatives. So if you look at the first one here, 3x squared times 5x would be 15x to the third power. 3 times 5 would be 15, x squared times x would be x to the third. So your job is to write in these little spots here 4 more ways that you might get 15x to the third power. Now one of them might be like x times 15x squared. That's a factorization. You could break this down into these two pieces. You could even make negatives. Negative 3x times a negative 5x squared. Negative times negative is a positive. You could just do x to the third power times 15. Or 15 times x to the third power. Many, many, many different ways that we could solve this. X squared times 15x would be another way we could do it. Those are 5 factorizations. The factor basically means we're breaking something down. So here's an example 1, or an example here. 2 parentheses x minus 1, if you did your distributive property, would be 2x minus 2 right here. Now what we're going to do in this case is take the 2x minus 2, and we want to break it down to get the 2 parentheses x minus 1. We want to find out what we could break this down into to get this answer. So what used to be the answer is, or used to be the problem, is now the answer. And if you notice, they both had a 2. And that's the 2 that's on the outside of the parentheses. It's called a GCF, the greatest common factor. So if we are looking at the 3x squared plus 3 here, if you notice, they both have a 3 in it. Both the 3x squared and the 3 have a common factor of 3. And we call it a GCF, a greatest common factor. So the 3 times the x squared and the 3 times the 1 makes the 3. Therefore, the 3x squared plus 3 can factor all the way down to 3 parentheses. Here's your x squared and here's your 1. So you take these 3's out and you put that in the front. The x squared plus 1 is left over for the back here. X squared plus 1. That's called factoring and breaking it down. This now breaks down into this. So if I have a 5y to the 4th minus a 20y to the 3rd, I need to look for a common factor. This 5y to the 4th, we could write it as 5 times y times y times y times y. You'd have 4 y's there. 20y to the 3rd, you could take the 20 and break it down into 5 times 4, and then y times y times y. So I underlined the common factors. The 5 is common because that's in both of them. And they both have 3 y's in common. So you could say a 5 and a y to the 3rd power is common. So here it is right there, 5y to the 3rd power. Inside the parentheses is what's left. You had a y left and a 4 left. Those are the only things you had left inside besides the ones that we took out. So y minus 4 is going to be in your parentheses. So 5y cubed and then y minus 4. That's basically called taking out a GCF. So here's a few practice ones. We got to look for a common factor. In this first one, if you look at it, this 16 is 4 times 4. A squared is A times A. B squared is B times B. So that's all of this broken out. 20 is 4 times 5. And A squared is A times A. So we look for commonalities. We look for things in common. Like there's a 4 here and there's a 4 there. There's 2 A's here and there's 2 A's here. So I'm thinking that the 4 and the 2A would be my common factor. So we're going to put 4 and A squared. Inside the parentheses, we would see what's left. There's a 4 and a B squared plus, there's a 5, and that's it. So that would be factored down. If I take this, I could factor down into these two pieces. Let's see what this would have. 15 is 3 times 5. 12 is 3 times 4. 27 is 3 times 9. 3 is 3 times 1. So you see the common factor has to be a 3. They all have a 3 in it. This one has 5 x's. That one has 4. That one has 3. This one has 2. This is the one that they all have at least. They all have at least x squared. You could take 2 x's out of all of them. So if I take 2 x's out of here, you're going to be left with 3 of them still, because there was 5. You took out 2. You got 3 left, and then 15 divided by 3 is the 5. 12 divided by 3 was the 4, but it's got to be negative 4. And it has to be x squared because you had 4 x's and you took out 2 of them. So there's 2 left. Now if I distributed, I could see that I get back to my answer. 27 divided by 3 is 9. You had 3 x's and you took out 2 of them because they were common, so you have 1 left. Negative 3 divided by 3 is just simply a negative 1. You had 2 x's and you took them both out. So that would be your answer right there. Okay, so I'm going to leave you those to try. I'll pause the video so you can see it. And here's a spot for you to do page 264. Here's section 6.2. It's called Difference of Squares. And once the video is over, then you can do your the page numbers. What is a perfect square? What is a perfect square? Like, perfect square looks like this. We'd have like all the same numbers. So the area of this perfect square would be 4. So basically that means 4 is a perfect square because it equals 2 times 2. Or 4 would be the same as 2 squared. 4 in this case is called a perfect square number. There's another one, is 9, 3 times 3. 16 is another one, that would be 4 squared. You can see that this is also the same as 3 squared. So those are all perfect squares. Perfect square is a number where it has the exact same 2 factors. A number with the same 2 factors. So let's see, is it a difference of squares? If you look at number 1, 9x squared minus 36. Get used to making this little tree thing here and showing me if it's a perfect square. And in this case it is. 3x times 3x is the same factors, and it would equal 9x squared. And also 36 is 6 times 6. So get used to making the little trees and showing me that those are perfect squares. So the answer to this one is definitely yes. It is a perfect square. And it is a difference. Difference meaning minus. Would this be a difference of 2 squares? Well, it has a plus in the middle, but what happens when they're different signs? still a difference of 2 squared. This is 2x times 2x, and this is 4 times 4. This is still yes. Because I could switch this around if I wanted to and put 16 minus 4x squared, and that would be a difference of 2 squared. So that is a yes. They're different signs, and they're both perfect squares. To factor a difference of squares, look at number 3, and it shows you take the x times the x, you take the 2 times the 2, you put them in the front, x's, you put the 2's in the back, and you put different signs in order to get a negative number. So in this case, I'd have 2x times 2x, and I'd have 5 times 5. This would be 2x and a plus 5, and this would be 2x and a minus 5. You got your 2x times your 2x gives me the 4x squared. The 5 times the 5 gives me the 25, and these two give me a negative. So I would have the same answer there. Try 5. M to the 6, you need to show me m to the third times m to the third. 16n squared would be 4n times 4n. You make your two parentheses, m to the third plus 4n, and m to the third minus 4n. (36), you can show me 6x times 6x, 36x squared, 6x times 6x. 25y to the 6 would be 5y to the third times 5y to the third. Then you know what your two parentheses are. You know the 6x's have to go in the front. The 5y to the third have to go in the back. And one's a plus, and one's a minus, and it doesn't matter which one. You can put the plus in the first one or the plus in the back. This one is a perfect square. 3a4b2. 3a4b2. Those multiplied together would give you the 9a8b4. And 49 is 7 times 7. So you have your 3a4b2 plus 7, 3a4b2 minus 7. That's breaking down a difference of squares. Here are some for you to try. I'll come around and see how you're doing on those. Try those. I'll pause the video while you try them. Here's examples 8 and 9. A little bit more to them. Not a lot, but a little bit. Here is 7x squared times 7x squared. Here's 3x to the third times 3x to the third. So if you remember from first semester, when you multiply the same base, you add the exponents. So this would be 7x squared plus 3x to the third, 7x squared minus 3x to the third. For the second one here, you've got to look for this GCF first, because right now they're not perfect squares. But if you look at 18, you know 18 is 9 times 2. And if you look at 50, you know that's 25 times 2. They both have a 2. And they also both have a squared. So I'm going to take out a 2a squared. And I'm going to be left with 9b squared minus 25a to the 4th. So that's a GCF. Now I can break these down. 3b times 3b, because that's a perfect square for 9b squared. 25a squared times 25a squared would give me 25a to the 4th. Oops, not 25, over 5. Sorry, 5a squared times 5a squared would give me 25a to the 4th. So you could make your two parentheses, and you're going to get 3b plus 5a squared, 3b minus 5a squared, and you're going to need to bring down your GCF, 2a squared. So that is if I take this, I can break it all the way down into that. Okay, so on these two, you see down here, we need to find the GCF first on both of these. This one, I'm looking at 32 and 8, and I'm thinking 8 goes into 32 and 8 goes into 8. And they both have at least 2 y's, so I can take out 2 y's. That's going to give me 4 minus 8 would be just a y to the 4th. So 32 divided by 8 is 4, both y's come out. 8 divided by 8 is 1. I could put a 1 there, I don't need to, but I could. It's not wrong to have it, it's not wrong to not have it. Let me get rid of this parentheses and put it closer. This is now 2 times 2, it's a perfect square. And this is y squared times y squared, it's a perfect square. So 2 plus y squared, 2 minus y squared, and we have our GCF of 8y squared out front. So the GCF had to come out first in order for me to break it down into the 2 parentheses. If I didn't break it down, these are not perfect squares until I broke it down. Here, I'm going to take out a 5. Because I know 5 goes into 5, and I know 5 goes into 20. So 5 divided by 5 is 1. 20 divided by 5 is 4. And then I'm going to leave my y to the 6. 1 is a perfect square. 1 times 1 is 1. 4y to the 6th would be 2y cubed times 2y cubed. Those two multiplied together would give you 4y to the 6th. So you multiply the same base, you add the exponent. So we get 1 plus 2y to the 3rd, 1 minus 2y to the 3rd, and you got to bring down your GCF, which is a 5. The GCF had to come first on those two. GCF was first. There's 3 through 75. There's a page for you to do those, multiples of 3. Now you might need to add some to your own sheet of paper. And then you have a worksheet, a matching one. I'll get you started on this. I'll do the top one for you. This one right here, you should show me where you get x times x and 7 times 7. So you're looking for x plus 7, x minus 7, and you will see it right there. I'm going to draw a line there that matches it up. But I do want to see this. I do want to see this work. You can't see my arrow that well, but I want to see that work on your paper. There. That work should be on your paper. And then the last one, you're going to fill in the missing boxes. Make it work. So if you see that this is 11 right here, a plus 11, then this had to have been a minus 11. So we would be looking to take this number 11 right here and put it in here, and then you can cross it out on your paper. And then you know 11 times 11 means they had to use 121 as the perfect square. So your job is to fill the next 4 of them in to make them work just perfectly. And I'll be checking those. All right, good luck.